This is The Grapevine on 99.3 County FM. I'm Lynn Pickering. And if you're a regular listener to the show, you'll know we've been following the Raise the Arrow project since its inception over a year ago. The Avro Arrow, or CF-105, was a supersonic, twin-engined, all-weather interceptor jet aircraft which was being developed by Avro of Canada until the Diefenbaker government's cancellation of the project in 1959. The OEX Recovery Group, Raise the Arrow, is led by John Burzynski, President and CEO of Osisko Mining Limited. Their goal is to locate and retrieve 9 free-flight test models of the Avro Arrow, which were launched from Point Peter here in Prince Edward County in the late 1950s. The team has discovered hundreds of artifacts and are in the process of identifying those related to the Avro Arrow. Last Friday, August 17th, 2018, was a historic first step. A few guests, County FM included, were invited to CFB Trenton to see the first Avro Arrow artifact recovered from Lake Ontario. John Burzynski explained how the object was recovered and its historic significance. As you listen to John and the conservators from the Canadian Conservation Institute, I suggest you go to 99.3 County FM's Facebook page, where you'll see a photo of the model.
When we recovered this model, we found it last year and we recovered it. It was a bit of a mystery to us because we weren't certain what it was. We were certain amongst ourselves that it was part of the Avro program, but there was something very different about the end. Over the winter we found we did some other research, we found some files. What this actually is, and we're almost 100% certain now, is it was the progenitor to the whole Delta Wing / Avro program. There were 3 of these that went into the lake, and then they sent out the tender for the Avro design from this. So it's like the grandfather of the Avro Arrow program. This one is a delta shape. They managed to have a look underneath. There was a tail on it that was broken off, and we actually have we found the documents that tell us it was a delta test vehicle or a DTV. And again, there were 3 of those fired off before they started the design of the Avro. So it's historically it's really, really important. And this is the first time any of these have been found on the lake. There have been other expeditions, but this is the first one of what we now know were 20 shot into the lake in different parts. There were 20 fired in there, so 1 down, 19 to go. Come and have a look. Don't be shy. Just don't touch anything. When we brought this up on Sunday, it had a thick covering of mussels. Kate and her team have been working to clear up the debris from sitting on the bottom of the lake for a little over 60 years. I guess it's been about 64 years since this one was fired into the lake. We're still making little interesting discoveries on this. There were some portholes. You can see that over on the center of the body there's a porthole with rivets on it. We're pretty certain there was telemetry equipment in there, but again, they'll determine that once they get it back to Ottawa. It's traveling to Ottawa on Monday, where conservation work and more work on it will continue. You can see the bent nose from where it hit the water. It was probably doing about 400 or 500 miles an hour when it hit the water. All of these, the idea was these were going to hit Mach 1.5, Mach 2 when they separated from their rockets. We were hoping to find something intact. This is almost completely intact except for the damage to the port wing. This is upside down, what we're looking at. Yesterday they had a look underneath it and found a slot for a tail fin. So we know it had a tail fin like the actual Avro Arrow. So what they were doing was they were testing the Avro Arrow basic delta wing design. And as they went into the FFM program, which was the object of our search when we started this, there were 5 models of, again, what we now know were 20 that were fired into the lake. The last 5 were identical replicas of the Avro Arrow. So we're still searching for one of those identical Avro Arrow models. We searched about 60 square kilometers of lake bottom. Probably have another 40 square kilometers to search to cover up that maximum area. We learned a lot in this last season, combined with what we did last year, as to where we think we'll find them. So, we're continuing that last little piece of the grid. We know really, really, really well right now where they aren't. But we've imaged about 1,200 different objects out there. I suspect there's something like 2,000 cultural objects on the bottom. So it's not so much as finding something, it's finding the right something. And again, we're looking for 5. And it's a lot like looking for a needle in a haystack of needles. Because remember, this was a firing range. They fired missiles, they fired different types of rockets. Of course, the series of free flight models and the TTVs, which they tried to track test the tracking devices on, and these DTVs, these Delta Test Vehicles, which were the start of the whole program. It was also an artillery range for about 20 or 30 years in the 1930s and 40s. So and then you would have had historical shipwrecks or a couple of plane crashes. So an awful lot of debris down there. And our biggest obstacle has been not finding things, because we found a lot of things. It's been determining what those things are. And so we've been sending down ROVs. We still have a lot of ROV target confirmation work to do. But even then it's difficult because everything has such a thick covering of mussels. And remember, this has been cleaned up for the last, 4 days, 5 days. When we first found it, that's why we weren't certain what it was, because we couldn't clearly get enough information from the object sitting on the lake bottom. But now that it's up here and we've seen some of the fine details, we're absolutely certain on what it is.
Can you just tell me, though, how you recovered this? Like, who went down?
Yes, we had the Wilson T. Cooper, which is a lake workboat that had a crane on it, capable of going down to 200 feet. We had the Atlantic Fleet Dive Unit out assisting us with target identification last week. They dove on some of our priority targets. They helped us putting the cradle down. We had a commercial dive team come in subsequently to move the model onto the platform, and we raised it last Sunday. We brought it over to the base here the following morning.
What was your reaction when you saw it coming up out of the water?
We were ecstatic. We'd finally, for the first time in 67 years, found one and brought it to surface. But it actually landed here at CFB Trenton at 8 Wing on Monday. So that's the first time we called it the landing event. It was the landing of the first of the Avro Arrow test models.
That's John Burzynski, expedition leader for Raise the Arrow. Once the object was delivered to 8 Wing CFB Trenton, the team from the Canadian Conservation Institute in Ottawa took over. Nancy Bibby is senior conservation scientist, and Kate Sullivan is conservator, archaeological materials.
We have an outstanding team of experts here. Senior archaeological conservator Tara Grant, metals conservator Monique Benoit. Nancy is a senior conservation scientist, has been involved with search for Avro Arrow models for the last 20 years.
Really?
Nancy Binney. And I'm a more recent addition to the team.
She's our team leader on the conservation side. She's taking it forward now.
We have a team of experts. I am just directing traffic and keeping track of the list. When you're working with people who know what they're doing, it's so easy. You just got to keep the list going.
So how did you take all the mussels off?
One by one with the scalpel, very carefully cutting them while holding them with either your fingertips or tweezers to ensure there was no damage to the surface below. We removed over 15 kilos of mussels from the upper surface of this object.
Just that object?
Yes.
Oh, wow.
2.2 pounds in a kilo.
Well, it's amazing that they were even able to find it.
It is.
Covered
it is.
Yeah, because it was lying flat on the surface in 4 inches of mud, so it maybe had 12 inches proud of the surface of the mud. Very small target this time of year to find, and not only that, they found this piece, but they also found a small piece about 12 inches by 4 inches, a piece of one of the tail fins that was located 10 meters away. So, they didn't just search where the main piece was, they did sweep searches looking for fragments. And they'll extend that again in the future. They will be going back to the same site looking for the piece of our missing wing, for instance. We have a broken tip on it. Yeah. So they hope to be able to locate those kinds of things.
Now, Kate said you've been looking for this for 20 years.
Yeah, actually, the Canadian Conservation Institute was approached way back 93-ish by Ian Farrar. He was one of the engineers with Arenda that were making the engines for the Arrow. And he was with a group that was interested in looking for the models in Lake Ontario. And that was followed up by other groups. There were other people interested, and they all approached CCI and said, if we do the searching, will you help with the conservation plan? And so we assisted in a very minor way because it didn't go anywhere because they never found the targets, thankfully.
I guess
the technology wasn't there. Yeah, but they did see lots of things, lots of booster rockets and other things, and it got people interested. And then a few years later, Mike Fletcher with National Geographic did a film, and the next year the Navy was out searching with 2 ships, the Glace Bay and the Kingston, doing searches. And their data has been fed into the data that the OEX recovery group has been generating as well. So they're looking at hundreds and hundreds of targets out there in the lake with things that are perfect rocks that look like arrows and arrows that look like rocks. And there's so many other things that were fired from that range, this being one of them. And, so many people involved in what went on. So it's an eventuality they'll find the right target. And it's a very different target from all the other things. Once they have it, I think we'll know immediately. So it's a waiting game and a survey game, and it's how much the lake lets you do according to the weather.
This object will be going to Ottawa on Monday, and what will happen to it there?
At that point, we have very kindly been offered space to work on it at the Space and Aviation Museum in Ottawa. They have a restoration hangar that they are going to let us use some space in. We do not have a space large enough to house this object at CCI, so we're going to be working there, which would be great because they have some larger pieces of equipment that we're hoping to also be able to take advantage of. So we will work there, and the goal is to get it clean and dry and stable and into such a state that it could go on display and be enjoyed by the public.
That was Kate Sullivan, Senior Archaeological Conservator with the Canadian Conservation Institute. Monique Benoit is Metals Conservator, and she described in detail how they removed the many thousands of mussels covering the model.
The mussels and the remaining, the little attachments, those fibrous attachments that mussels have, which is how they attach to a surface. If we were to leave the mussels and or their attachments, once they start to decay, they'll attract a museum pest we refer colloquially to as a clothes moth. So once we move this object back into the museum setting to finish the treatment, we are trying to reduce the chances of there being, an infestation of insects in the museum collection.
And what do you do to reduce the chances?
So what we do is physically remove them. So we initially started by just holding onto the mussel shell itself and then using a scalpel or something sharp to slice through the attachments, the fibrous attachments. But there are up to 20 of these fibrous attachments per visible mussel shell, which made it very difficult to do because you can't see it necessarily with the naked eye other than a clump of looking at things that look like hairs. So one of the techniques we use to remove this type of material is called CO2 or dry ice cleaning. So basically what it is we buy a block of ice. So dry ice, if you think about liquid nitrogen, it's got that smoky white smoke, or the white smoke rather. So this is really just CO2 captured and contained in a block that's about minus 80 degrees Celsius. And we have a machine that will take a block and shave it with a razor and with compressed air blow it through a nozzle. So it works like traditional sandblasting, but rather than using sand or metal or glass beads, we use basically crushed dry ice. So it can be very abrasive. So of course with expertise you have to practice and learn your technique and your materials, but it works very, very well for removing things like this.
John Burzynski and Nancy Bibby assess the value of the object.
We have documents on the cost of the program and what they were spending. Each model cost approximately $100,000.
In 1958, they estimated $100,000 for an arrow model. So they were a precision tool, not a $38 model from Walmart.
Yeah, that's right. And if you put the net present value on, current value of the dollars, that's equivalent to about $1 million in today's dollars. So this is a $1 million model.
Inside these devices, even in this one, and in the arrows as well, there are ports and access points where they loaded in batteries and telemetry equipment and other things that were part of the mechanisms for tracking. They had people tracking them from the ground using high-speed cameras. They had people tracking them using radar, which didn't work very well until they were maybe 10 seconds into flight because the radar it has to be a certain height. And they also had telemetry, so radio-based equipment beaming out signals to ground so they could follow it, along with all sorts of electronic equipment, information like temperature and how it was performing. So there was an electronics package in there, probably behind the section where it's bent, where we hope to find a telemetry package that would be very much like what we would find also in an arrow model. So at some point we like to do imaging so we can see what's inside, because we think we need to get at it. And that's one of our hesitations towards flipping it over so the right side is up right now. It's been sitting for 60 years in this orientation, and the concept of flipping it and disturbing the internal things floating around, we'd rather wait to do that in a controlled environment.
So we'll find out about that when you take it back to Ottawa.
Yes, it's high on the list, because think of it as a hollow object right now. We can't just treat the outside, we have to treat the inside as well. And even the wings have structure, they have hollow areas. And all of that, you have to stabilize the top and the bottom of everything, every surface. And right now the approach is minimal intervention. We're not putting any chemicals on it yet. No stabilization chemicals. That's a drastic decision. Once you've done it, there's no going back.
And what do you mean by stabilization?
Well, you could dip it into a preservative tank, such as they use for mothballing aircraft. That's an approach in the States. If the plane's going in the museum, take the motor, dip it in a solution like they're not degreasing solutions, they're oily solutions with corrosion inhibitors. We don't want to do that, because once we've done that, we can't study it the same way we can now. So we have to keep it stable until we've done our studies, and then we're ready to decide. They have to figure out how to treat it. That's part of the science of it, and study what the materials are made from.
What was really, really fascinating about this one, we were excited when we recovered it on Sunday and brought it to base here on Monday, but it was Tuesday when we got really excited, because what we realized after we got some of the muscles off was that we had found the grandfather of the whole Delta Wing project, which led to the design of the Avro Arrow. This is one of only 3 models that they fired off that led directly into the free flight model program, and it's truly the starting place of the Avro Arrow.
And so the search continues. My thanks to expedition leader John Burzynski and his team, and the conservators Kate Sullivan, Nancy Bibby, Monique Benoit, and other participants from the Canadian Conservation Institute. Follow the progress of the expedition at raisethearrow.com or on their Facebook page. And of course, we will continue to cover this fascinating project, which is so closely entwined with the history of Prince Edward County. I'm Lynn Pickering for 99.3 County FM, the voice of the county.